Hello everyone. In this video we will continue to examine topic 5.2, the heating effect of electric currents, and in particular we will continue to unpack Kirchoff's circuit laws. Alright, so we can use Kirchoff's first law in the conservation of charge to solve problems. So here's an example. Assume that the brightness of a lamp, the brightness of a particular light bulb, is related to the current through it. It's actually kind of a tricky question in general, like to what extent that is true, but for a simple approximation, it's pretty good. So if that's the case, then rank the brightness of the lamps in the circuit below, assuming all the lamps are identical. So how does the brightness of A compare to the brightness of B and C and D? Well, okay, how are we going to answer this question? Here's how. Apply Kirchoff's first law to either junction 1 or junction 2. Let's start with junction 1. The current through lamp A, is going to be related to the brightness of lamp A. The higher the current, the higher the brightness. So using Kirchoff's law, we can say, oh, well, the current through A has got to be equal to the current through B plus the current through C. So we're applying Kirchoff's law, first law, to this junction right here. Notice B and C are supposed to be identical, so in fact we can actually say the current through B and the current through C are also going to be the same. Therefore, we expect the brightness of A to be bigger than the brightness of B and the brightness of A to be bigger than the brightness of C, where B and C are next to each other. Are equal to each other. Or the brightness of B and the brightness of C are equal to each other. Well, what about bulb D, right? Is it less bright than that? Is it more bright? Well, now we can think about this. Consider junction 2. How does the current through C compare to the current through B and the current through D? Well, the relationship is that the Kirchoff's first law says the sum of the currents in is equal to the sum of the currents out. And so the current through B and the current through C must add together to equal the current through D. And so, long story short, the brightness of A is going to be exactly equal to the brightness of D, and the brightness of B and C will be less than that. Notice that the current will be exactly half, although we haven't proven that yet. But if the current is exactly half, it's not obvious that the brightness will be exactly half. There's an extra step there. As a bit of vocabulary, note that B and C are wired in what is known as parallel. Whereas, for example, the battery and A are directly connected, that's known as series, and we'll see that more later on.